10, 9, 8, 7, 6, 5, 4, 3, 2.
When you first hear someone mention EDM, electrical discharge machining might not be the first thing that comes to your mind, but throughout the course of this video, we hope to change that. EDM is a very precise machining process that is used to make some parts with some insanely tight tolerances. When current-carrying conductors are brought close together, in this case an anode and cathode, an electric arc is formed between the two conductors. This spark generates intense heat which makes it capable of melting and eroding away metal. When both the anode and cathode are made of the same material, the electrode connected to the positive terminal generally erodes away faster. Therefore, the workpiece is generally connected to that positive terminal. Throughout this whole process, a constant gap of about 0.005 to 0.05 millimeters is maintained to prevent it from short-circuiting. The first type of EDM we're going to look at is hole drilling EDM. In this process, deionized water is being sprayed on the part with a nozzle, but it is also coming out through small holes in the electrode. This process is a good one to demonstrate the fact that the electrode is indeed not in contact and drilling a hole, but rather slowly melting metal away with electrical sparks. You can see that because this part is not clamped or held onto the surface in any way. The only force causing slight movement in the part is the force from the deionized water being sprayed on it. The next process you are seeing demonstrated here is called die stamping. For this, specifically shaped electrodes have to be made, and then they are used to transfer that shape over to the part. Think of it like taking an object and pressing it into sand, leaving behind only the outline of your object. This process is very useful for making repeated products that have simple enough geometry that they can be made into an electrode. And once again, although it may seem like pressing or drilling is being done here, there is still a constant gap in this process, allowing only the electrical current to melt away metal. The back and forth movement is to allow microscopic metal shavings to escape and deionized water to continue cooling the part. Our final process we're going to look at is one of the most popular, and it is called wire EDM. In this process, there is a continuous spool of wire being ran through the part that is being used as the cathode, while the part itself is connected to the positive terminal and therefore it is the anode. The process is the most precise and it is capable of producing parts within a tolerance of 0.00254 millimeter accuracy, which is equivalent to taking a human hair and cutting it into 40 pieces. It's also important to note that this level of precision requires different blanks for parts that are going together because the wire used can only be as thin as 0.15 to 0.02 millimeters. That means this process can be pretty wasteful, but it is worth it for the quality of parts it produces. This process is usually done in a tub of deionized water that acts as a resistor and helps cool and clean the part.